Hey guys, welcome back to tutorial series Introduction to Docker. In this video, we are going to talk about the pods in Kubernetes. This is JainishShah. I'm a software developer, and these are the links to follow me on Twitter, GitHub, and LinkedIn. So, what is pod? In Kubernetes, the pod is group of one or more container which shares the same storage or which can share the storage and network. uh, and it will follow the specification or the definition that you provide uh, at the time of creating the pod. Now, container within the pod shares the same IP address and the port, and they can find each other via localhost. Versus container in different pod have different IP. So So for example, let's say we have three pods. Pod one has only one container running, and you can see it has the IP address which is 10.10.10.1. Pod two has a two component. It has the one container and it has one volume. Now, that example of that can be that you have an Nginx container running, and in the shared volume you have an index HTML page, which is like just a simple HTML page for your website. Now, example three, pod three has two containers and one shared volume. Now, if you can even make both container to access the shared volume. Now, example of this can be that you have a web application, but before starting the web application, you want to use another container to make sure that this volume is ready to write files, right? So that can be the combination, which is pod three with two containers and one shared volume. Now let's talk a little bit about phases of the pod. So when you tell Kubernetes to create a pod, it goes through this phases. The first one is pending. Pending means that Kubernetes has API server has accepted that it needs to create a new pod, but it's still in the process of running the container. Now, this includes even, when a container is pulling the image from Docker registry, it will still be in pending state. This Then phase two is running. Now, running is you have your container is assigned to a node to run, and container has been created, and at least one of the container in the pod is running, right? So it will be in running state. Succeeded means all the container have created, or if you have like something like init container, those are executed successfully, then it will be in success phase. Failed means, when you create a pod, but because of some reason, your pod fails, like for some application, if it gets out of memory because you have provided very limited resources, and those resources are not enough to handle the load of that application, then your container will exit with the error out of memory, and in that case your container will fail, so it will be in fail state. The unknown stage, and then there is one more, which is unknown phase, which is like, uh, for some kind of error that occurs which are not part of the above four phases, which is unknown. Maybe it occurred due to some issue in the node or in the master, so it goes to unknown state. Now, there are container probes. Now, probes are to make sure that your application running inside the container is healthy. So these are some way to identify that. So first one is liveness probe. Liveness probe. It indicates whether the container is running. So when you say that, hey, create a pod uh, which deploys Nginx. Now, so as soon as your container is created, the liveness probe will make sure that your container is running, right? Now, liveness, your container is running, but that does not mean application inside container is running. Like sometime it can happen that you are deploying some application, like container is running, but inside the container application is having some errors, and because of that it cannot serve the request. So most of the time you get 500 as a response code for this kind of errors. right? So liveness probe is to make sure that your container is running. And then there is a readiness probe, which is to make sure that your container is running and the service inside the container is ready to accept the request, so which can eliminate the problem of if you have Nginx, but because of some reason the Nginx is not working inside the container properly. Instead of 200, it will give another error code, and Kubernetes will identify that the container is not ready to serve request, and it will remove the pod or remove the container from the load balancer, or it will remove it from pod's IP. So that's how it can manage that container is ready and ready to serve the application. Then there is a third, which is a startup probe. Now, just to mention one thing, by default, if you don't provide liveness probe or readiness probe, every time those are marked as a success, right? Regardless of your container is running or your application inside the container is running, it will always say it's successfully running. So you will need to assign the liveness or readiness probe. And now to assign the probes, you can use three methods. One is exec method, which means you can run a command inside a container to verify your application is running. The second is HTTP GET. So you can trigger an unauthenticated endpoint of your application, and based on the response, the Kubernetes will decide whether container is or application inside the container is running or not. And the third one is TCP. So you can even request on a TCP port, and based on the response, it will decide whether the container is healthy or not. The third is startup probe. By default, when you start container, this is off or this is set to false until it passes the startup probe and your application is notified as a successful. So these are the three props that you can use. Uh, Now let's go and look at example how you can create pod. So this is my GitHub repo where I have uploaded the code for creating the pod. The README talks about how you can install Minikube if you haven't installed it already, and then later in the part it says how to create a pod. So let's go and get started. I have already fetched the code. So here you will see a pod.yaml file, which is a definition, which is the template that Kubernetes understand, which is the definition of what pod I want to create. So we are using API version V1 kind. We are describing it as a pod. Some metadata to provide some information or metadata to the running pod. Now, in this pod, we will have only one container, but you can have multiple container as I mentioned in the description. So we are going to create a node version application, which I describe how to create, your container or your Docker image in our previous series, Introduction to Docker. If you haven't seen it, make sure you go through it. So I want to deploy an image called JainishShah 17 node version, and we are going to fetch the latest tag of it. Image pull policy, I'm keeping it if not present. There are two different options. If you can keep always, which means every time you create a pod, it will try to pull the image regardless if it's already available in the node. Then we are specifying the resource. Limit stands for the upper limit and the request is the lower limit. So to begin with, we are providing 100 MB as a minimum limit, and 200 MB as a maximum limit. And also we are providing a friction of some CPU. Now these are the readiness props. So my service provides a response on the root, and it will be running on port 3000. My application inside the container is running on port 3000. So I have created a readiness and liveness probe, which can make a HTTP GET request on this port, and based on the result, it will notify that container is healthy or not. Now let's create the pod. So before that, I just wanted to show you guys that you can do get pods. It will show you that if any pod is running, and right now there is no pod running. So let's go ahead and create your first pod. To do that, you can do apply and -f, which is to provide the file path, and I'm going to give the file path pod.yaml, and you can see it says the pod or node version is created. So let's go. I will just clear the skin and run get pods now, and you can see the pod is in the running state, which means it's already assigned in the Minikube node or Kubernetes node, but the state is not ready yet because of the readiness probe. Now, it will take little while to get it ready because it needs to do the health check. But meanwhile, we can go and see the logs of this container. I'm going to use kubectl logs -f command, which can tail the log, and you can see our liveness and readiness probe has started hitting the root path, and they are getting 200 requests. This is log from my application, so which means application is running. And now if we see, uh, we might see the pod is created and it's in healthy state. You can also, for debugging purpose, you can also exec inside the pod. To do that, you will need to do kubectl exec -it is for interactive mode. You specify your pod name, and at the end, depending on what uh, base image your container uses, you might want to provide bash or /sh. So I'm inside the container. If I do ps-ef, I will see node application running. Right, so let's get out of the container and let's kill the container or kill the pod. And you can do it same way. The command is kubectl delete -f, and you provide the file name, and it will terminate the pod. So it goes very quickly, but if your load is more on Kubernetes cluster, you might see there's termination uh, status for some time before it kills the node, kill the pod. So that's it for the this video. It was about how to create your first pod. In the next video, we will cover deployment. If you have any question, feel free to add your questions in the comment. I will try to answer those. Don't forget to subscribe to my channel and give me thumbs up if you like this video. Thank you.